Okay, we've mixed exercise 6 from the first year core textbook. We're on question 24, which is a problem solving one. Now, there's actually a couple of different ways you can tackle this. You can either do it by, so I'll show you the method that I'm not going to use to start with. Right, so one method is if you've got 3 points on the circumference, so this is not a sketch of this question to scale, their perpendicular bisectors will cross. So if there's the perpendicular bisector of AB, and there's the perpendicular bisector of BC, and they will intersect at the centre of the circle. So you could find the midpoint of AB and the gradient of AB, and then get the equation of its perpendicular bisector, do the same for BC, and find where they cross. Now, that's the method they use in solution bank. So I'm actually going to just show you an alternative, and then you can use whichever you're happiest with. So I'm going to do it algebraically. So I know that the equation of a circle is going to be of the form x minus a all squared plus y minus b all squared is r squared. And I've got 3 sets of coordinates. So I've got minus 4, 0. So if I substitute that in, so if x is minus 4, that becomes minus 4 minus a all squared. If y is 0, that's just going to be minus b squared, which is b squared. Okay, I've then got the coordinate b, which is 4, 8. So an x is 4, y is 8. And I've got the coordinate 6, 0. So an x is 6. Yeah, just make sure I've written that down correctly. So an x is 6, y is 0. So again, that will be b squared. Okay, so I've got 3 equations from that information they gave me, 3 unknowns. So it should be solvable. I now just need to think about kind of the nicest way to solve it. And one good thing about how they've structured this question is the fact that they've given me 2 coordinates where y is 0. So I am going to start using those, because I think I would, even if I hadn't spotted that, I would be thinking they look the simplest. And I certainly don't want to start square rooting things. So what I'm going to do is say, well, look, they both equal, it's a very hard colour to see, isn't it? They both equal r squared. So that means I can just put them equal to each other. So I'm not going to worry about these brackets for now. So that's the top one, and that equals r squared. And that's the bottom one, which also equals r squared. So they must equal each other. So the reason why it's so handy that y was 0 on both of those is I could then subtract b squared from each side, and I've got a quadratic just in a. Okay, so I'm going to be able to find a, and then I'll think about finding b and r. Okay, so as I said, there is more than one way to do this. And if you look at the solution bank, there's links in the study directory. If you look at the solution bank answers, so the textbook just has the answers, but solution bank has all the working. They do tackle it in a slightly different way. Okay, so I'm going to multiply out the brackets. So minus 4 squared, and then I'm going to have a minus 4 times a twice, and then an a squared. So I'm just squaring out those brackets, and then that gives me 36 minus 12a plus a squared. So it gets even better. So I don't even have to worry about solving a quadratic, because I can just subtract a squared from each side. So if I add the 12a over to the left-hand side, minus the 16 from the right-hand side, I get a is 1. Okay, so now I want to think about trying to find b or r. So that's not going to be quite so easy, I don't think, but still doable. So now I know a. I think what I will do, yeah, so obviously I can't use the 2 I've highlighted in yellow again because I've already used those. So I know that a is 1. So let's use the second and third. So let's get even more highlighting going on here. So now let's look at those 2. Okay, so if a is 1, the second one becomes, let's write it all out. So So looking at the second one, it's 4 minus 1 all squared plus 8 minus b squared. So I'm going to square those brackets out. So that will be 64 minus 16b plus b squared. Okay, the one below it, the third one, is going to become 6 minus 1 all squared plus b squared equals r squared. Okay, so let's tidy those up. So the top one will become, so what's that? That's going to be 3 squared, then plus 64. So that's going to be 9 plus 64. So 73 minus 16b plus b squared equals r squared. The one below it, so this one is going to become, well, so that's just 5 squared plus b squared equals r squared. So if I do the same thing again, they both equal r squared. So if I put them equal to each other, again, I don't even need to solve a quadratic because the b squareds will cancel. So I'm going to add the 16b over to the right-hand side. I'm going to minus the 25 and get b is 3. And then I'm going to go back to my original equations, pick the one I think looks easiest. So I don't think I can highlight it again, you'll be able to see it. So I think that I would say is the simplest to substitute those values into. So it was 6 minus a all squared plus b squared equals r squared. So I now know that a is 1, so that's becoming 5 squared. I know that b is 3, so r squared is 25 plus 9. Okay, so that's all I needed. Yeah, I needed a, I needed b, and I needed r squared. So x minus a all squared plus y minus 3 all squared is r squared. So I do think for that particular question, if you have a look at the solution bank method, I do think this is a quicker way for this one, but this was only quicker because we had y is 0 in 2 of our coordinates. So if we hadn't had those zeros there, we could still have done it this way, but it would have been, I think, a slightly trickier method. We get too cocky. Oh, hang on. Oh, for goodness sake. Shouldn't have got too cocky there. Turns out I can't do 25 plus 9. That is not 24. That is 34. Okay, now we've got it. Just going to double check the rest of it as well. Make sure I have anything else daft. No, we're good.